This video is going to be all about graphing compound inequalities. This is a topic that some people struggle with when you get to more complicated examples, but the basics I find that a lot of people do okay on. So we'll talk here about the basics, and then in later videos I'll go into some more detail on compound inequalities. But there are two types of compound inequalities. The first one is an AND problem, and the second one is an OR problem. AND problems do not always have to have the word AND here when you're graphing them. An OR problem, if it's just a compound inequality without any absolute values, we'll get into absolute values later. But if it's just a compound inequality, it needs to have the word OR to be an OR problem. Okay? So AND problems should say the word and it could also, you sometimes have these as well. So if you have like a 2 and a 10, this is also an AND problem in disguise. I'll show you how to split those up and put them together in a little bit, or possibly in a later video. So here we go. In an AND problem, the key is you're going to be shading the overlapping parts only. Okay, you need to find out where both inequalities that you're shading are true. And I'm going to use a 3-number line method to help you guys graph these. In an OR problem, they don't need to overlap. You're just looking for where either one of the inequalities is true. And if one of them is true, then you're going to shade that area. So there's a fundamental difference between AND and OR problems when you're graphing. You need to make sure you're doing these problems differently. Okay? Now, typically, and this is not always true, but for the purposes of an introductory lesson here, typically with AND problems, when you shade, you're going to be shading numbers in between. They'll usually shade something like this, or if you have closed circles, they'll shade something like that on a number line. Now, in an OR problem, typically, you're going to be shading outwards. So if you have open circles or closed circles, they'll look usually something like that, one or the other of those two types. Now, there's another type of graphing where it's possible that both of your lines, after you solve it, could be pointing the same direction. I'm not going to get into that today, so I'm just going to kind of cross these out. That's something I'll talk about maybe in a more detailed video, so I won't get into that. That's not a huge topic in a lot of Algebra 1 and sometime Algebra 2 classes as well, so I won't get into that today, but I may get into that later. So let's go ahead and graph a few of these guys. Okay, we'll start off here with number 1. So the first one says x is greater than 3 and x is less than 6. So my first instinct here should be that I need to find out where these two graphs are going to overlap. Okay, so to do that, I'm going to graph them each separately on a number line. This first number line and the second number line are going to be to show my work, and then the last number line is going to be my answer number line when all is said and done. So I have x is greater than just greater than 3. So I'm going to go out to my number line here. I'm going to put an open circle at 3. Since it's greater than, I'm going to shade all the greater or bigger numbers, which is to the right here. So that takes care of the first graph. On the second graph, I have x is less than or equal to 6. Or excuse me, I keep saying or equal to, just less than 6. So what we're going to do is put an open circle at 6, and we're going to shade to all the numbers that are less than 6, which are the smaller ones down here. Okay. Now, since this is an AND problem, we're looking to see where the two graphs overlap. And if you look here, everywhere between 3, not including 3, and 6, not including 6, is where the two graphs overlap. So that would be our final answer there. Any number between 3 and 6, not including 3 and 6. So this would be the shaded final number line for that first problem. All right, so I'll clear this out and we'll free up some space for the next one. Okay, the next one says x is greater than -4 and x is less than or equal to 5. Okay, I'll do this one a little bit faster. We're going to go to the first number line. We're going to put an open circle at -4 because that's not or equal to, and we're shading greater than, so that should be off to the right here. That's the first inequality, x is greater than 4. Now with the next one, we have x is less than or equal to 5. So I'm going to put a closed circle at 5 because that has the or equal to line underneath telling us that this is a closed circle. And now this is less than, so I'm going to shade everything over here to the left. And you can see that, again, if I'm looking for where these two graphs overlap, because this is an AND problem, it's going to be anything in between these two numbers. So from -4, now that's going to be an open circle again because it's not including -4. They don't overlap there because the blue graph does not include -4. And all the way out here to 5. Now 5 is included in both of them because that's a closed dot. And then we're going to go ahead and shade in between. Okay. We'll go ahead and try a third problem. Feel free if you want to pause the video and you can see if you could try this one on your own here. Okay, so for number 3, we've got x is greater than 4. So I'm going to go ahead. Again, this will be an open circle, shading to the right. And we've got x is less than -3. And now this is an OR problem. So the big difference here, since that says the word OR, is we don't need these things to overlap anymore. It's just where one of them or the other one is. So if you look carefully, over on the left side of -3, one of the graphs is here. So we're allowed to shade this in our final answer in an OR problem. Now there's nothing in the middle, so I can't shade in the middle. So I'm going to go out here to the 4 again, not including the 4. And you'll notice that, again, once one of these graphs is out here, so I'll shade off to the right. And I've got another way to explain this that might help you out, and I think I don't know if I want to get into that in this video. We'll maybe do that a little bit later. But that would go ahead and be your graph for this problem here. So you would have anything -3 or, not including -3 or smaller, or anything greater than 4. Okay, and we'll go ahead and try 3 more here. Next one, we've got x is greater than or equal to 3, or x is less than or equal to -2. And you might be getting the pattern here. Some of you might be able to graph this with one number line. The one thing you have to be careful about, and this happens later, is that it is possible that both of your lines could end up going the same way. So you can't just assume that the lines go out. You really should be taking 3 number lines to graph them, if you're just starting out, because you may get some problems thrown at you where both lines are going the same way, and then it'll be a little bit different. So bear with me here for now. So we got x is greater than or equal to 3. That would be this line. We've got x is less than or equal to -2. That would be going to the left. Okay, and since, again, this is an OR problem, they don't need to overlap, which is okay. So we're okay to the left down here, and we're okay to the right of the 3, but there's nothing in the middle here, so I'm not allowed to shade in the middle. As long as one of the graphs is there, I shade, and then again, my final answer number line is down here in the green. Okay, 2 more to go. These are a little bit different. At least they look different. Okay, I'm going to show you 2 ways to do these problems. The first way will be similar to the way we've done these. So if you have 2 is less than x, which is less than or equal to 5. This, when you don't see the word and or, and it's, your x is surrounded by 2 less than signs like this. Typically it's with less than signs. It's possible they could use greater than signs, but usually they'll flip it around so they're both less than signs. This is an and problem in disguise. Okay, and here's how we're going to split this up. So to be an or problem, it must have the word or. But for an and problem, we can split this up into 2 inequalities here. So what I'm going to do is take the first piece. So I'll take all this stuff on the first part of the inequality, and I'm going to write this as x is greater than 2. I just flipped it around to put the x on the left side. You could write 2 is less than x. That's the same thing. Now I'm going to sneak the word and in here. And the other inequality will be, well, from the middle out to the 5. So it would be x is less than or equal to 5. And what we'll do is we're going to go ahead and put an open circle at 2, shade to the right. We'll go ahead and put our closed dot at the 5, this would be going to the left. And you can see that since it's an and problem, they're going to overlap in the middle here. So our final answer number line will be down here. They'll overlap in the middle anywhere from 2 to 5. Okay. Now, I know I told you guys you always have to be careful and check to make sure that your graph isn't doing something funky. And again, I'll show you some of those things in later videos. But when you have a problem like this with 2 less than signs, like number 5, this problem will always go in between. So if you see that, no matter what, you are always going to be just shading between the 2 and the 5 for those types of problems. Okay. The only way I could think that that would not happen is if you had the 5 and the 2 switch, but then your inequality wouldn't make sense anyway. So we'll go ahead to one more here, and I'm going to graph this one just using a shortcut here. I'm going to just jump right to the answer number line. We said that when you have one of these with 2 less than signs, it's a fancy way of saying that you're going to shade anything, or x is anything, between 1 and 6. Okay, so I'm going to start by putting a closed dot on the 1, since that's an or equal to, and I'm going to put an open circle on the 6, and instead of having to graph this 3 times, we can just jump right to the answer here. Again, this is just a fancy way of saying that your solution has to be between 1 and 6, including 1, but not including 6. And again, this is a little bit of a brief intro. This is not everything you need to know about compound inequalities, but it's a good introduction so you can start graphing some of the simpler problems on your own.